Okay, higher order maps means 4, then 5, 6, 7, and then where do we stop? Where can't we continue? A 5-variable map, meaning you have variables A, B, C, D, E, and A being considered the most significant, and the here A, B, C, D, E, A being the most significant, and then make it for 2 4-variable maps. The one on the left is for A0. The one on the right is for A1. We have already seen 4-variable maps, and therefore we can do all the mappings we want in the 4-variable maps on the two sides, for the A0 and for A1. But then visualize these maps one on top of each other. Okay, if you visualize these on top of each other, then you see that if you look from the top, you see, for example, that this one is adjacent to this one, right? Because this one, if you look from the top, you see that they are along this z-axis. So what we are really doing with the 5-variable maps is that we are extending our definition of physical adjacency not only to horizontal, vertical, also in the z-axis, also these are adjacent to each other. Okay? Considering this, let's do the, again, essentials, prime, and then the prime implicants and so on. So what I'm going to do is, what I'm going to do is first look at these 4 on the lower right of the map of A0. And then I look in the other map, then I see, oh, these 4 are sitting exactly on top of the other 4. And therefore, these are adjacent. Okay? And therefore, instead of writing these 2 individual ones, I say, well, the one on the left is A bar, B, D. The one on the right is A, B, D. And then these 2, like I said, are adjacent. Since they are adjacent, A drops because they are in 2 maps. One is A0, one is A1, and therefore this becomes just plain BD. All right? So that's one. And then, what else do I have? Look at the left map, the 2 pink ones. Okay, the 2 side pink ones. 1, 1, 1, 1. This gives me 4. Okay, once again, if you want to write the map here, this becomes, write the expression here, this becomes A bar, C bar, D. You want to write the expression for this pink one on this side. This is A, C bar, D. Well, these are adjacent because of my new definition of adjacency in Karnaugh Map, which is one on top of the other one. This and this are also adjacent, and therefore these merge to C bar D. Okay? What else? These 4, the blue ones, okay? Yeah, I love colors that I can distinguish. These 4 are B bar, C bar. But then they are only on the left side, therefore they become B bar, C bar, A bar. Okay, B bar, C bar, A bar, because it's only on the left. All right, what else do I have? I have an interesting one. A 1 here and a 1 there. Okay? I do have other prime implicants, but let's take care of this first. This one is, if you look at the terms there, this is B bar, C, D bar, E. Okay? On the right side becomes A, this. On the left side becomes A bar, B bar, C, D bar, E. But since it is both on the right and on the left map, and therefore A does not have any participation, and therefore this becomes this. This is my minimal realization. But then do I have other prime implicants? Okay, let me do something here. This one, this, how do I mark this here? This one is C bar D, which is this. Okay, and then I have this one, which is on the two sides is BD. Now, do I have other prime implicants? Of course I do. This is a prime implicant. Okay. Why didn't I consider it? Because I have essentials that have already taken care of all my midterms. The blue one is essential because of this. Okay, and only because of that. The brown one is essential because of this. Not only because of that, also because of this, also because of this, also because of this. Okay, but again, one is enough. Okay. How about the pink one? Is the pink one essential? See, the pink one is not essential due to this, is not essential due to this, because the blue one also covers these two. Is not essential because of this, because the brown one also covers it. Is not essential because of this, because again, the same thing. Is not because of this, is not because of this, but it is essential because of this or because of this. And therefore, the pink one is also essential. All right, considering the essentials, this is essential. Okay, let's check mark all those mean terms that have already been covered. The blue one covers this, 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 this. The brown one covers these four and these four. The pink one covers these two, again these two, and then again these two, and then again these two. So only two of them are new. And then the light green one is also essential because of this one over here. Okay, because of this is essential, and therefore including that covers that one and this one over here. Now, do I have check marks everywhere? Yes, I do have check marks everywhere, and therefore by just listing the essentials, all my mean terms are covered. Is this a unique implementation? Yes, it is, because just by picking the essentials, I was able to cover everything. Are there other prime implicants that are not used? Yes, I do have this prime implicant that is not used, this one over here, which is not used, which I don't really need it anyway. Okay. Any other questions? No, this is a good implementation of a 5-variable Karnaugh map. How about 6-variable? I'm not gonna do this 6-variable, but then look at it this way. See, the 2-variable map was like this, right? A, B, 0, 1, 0, 1, and then you put the ones in there. Now, what I'm saying for 6-variable map, take the 2-variable with the variables A and B, and then put stick 4 Karnaugh maps in each of these boxes. That becomes AB for the outside, then C, D, E, F for the 4 here. Okay, which I'm showing over here. The same way 2 horizontal ones are adjacent. If I have something here and here, these are adjacent. If I have something here and here, these are also adjacent. Now, if I have all these 4, yes, all these 4 on top and 4 at the bottom are adjacent. Okay, so you look at the individual maps first, and then consider the big picture, the 4 Karnaugh map situation altogether. Let me do just a few more, and then we leave this subject completely. Let's say I have ones here, I have ones here, I have ones here. Okay, this is okay. But then this and this also form a map. But then the 2 on the lower left and these 2, definitely they don't form a map because they are diagonally across. Okay, but the red one, the on top and the bottom, they do form a map. Let me do one more thing here. Let's say I have 2 ones here as well, and therefore these 2 and these 2, they are adjacent. But then again, these are not. Okay? You don't really need 6-variable Karnaugh maps. I just said that so that you can exercise the definition of adjacency a little bit more. And beyond 6, forget it. Beyond 6, what we have to do, we say, well, let's talk about more complex structures instead of gates. Let's go up to components that are already made, and then I use those components. We get to that later. And or if you have really functions that you want to implement using, let's say you have 7, 8, 10 variable, then you have to use computer for programs for minimization of those. All right, so I'm done with the 5-variable, 6-variable map, and then we go into the next subject, which is don't cares. Okay, what do we care about don't care? Well, we talk about that.